In today's lesson, we are going to talk about chain rule. Under this, we are going to look into meaning of chain rule, the chain rule formula, when do we use chain rule of differential calculus, how to use chain rule of differential calculus, and application of chain rule in trigonometry. The chain rule refers to the method of differentiation that is used in differentiating a function of a function. That is, when we have a composite function and we are told to differentiate that function. In that case, we employed the chain rule of differential calculus. A function of a function refers to a function that has a function in itself. The chain rule formula is given by the y over the x is equals to the y all over the u multiplied by the u all over the x. Now, when do we use chain rule formula? The chain rule formula is used when we are given a function that is a composite function and we are told to differentiate this function. In that case, we employ the chain rule formula. Don't forget that a function and a composite function is a function that has another function in itself. So in that case, we make use of chain rule formula to differentiate such function. The function must be differentiable, that is, we must be able to differentiate that function. Now, the question is, how do we use the chain rule of differential calculus? Since chain rule is employed in differential calculus when we are told to differentiate a composite function, the first step is to identify the outer function and the inner function. The second step, we differentiate the outer function and the inner function. Then the third step is to multiply the derivative of the outer function with that of the derivative of the inner function. We have some example in this place. Find the derivative of the following function. Y is equals to 2x plus 4 raised to the power of 4. To solve this question, the first step is to identify the outer function and the inner function. Now in that case, I will let this is the inner function. 2x plus 4 is the inner function. So in that case, I will have let u is equals to 2x plus 4. Since I have set the inner function as u, then this function will be y will be equals to y is equals to u raised to the power of 4. So in that case, this is the inner function and this is the outer function. Now the next step is to differentiate the inner function and the outer function respectively. If I want to differentiate this function u is equals to 2x plus 4, recall from the power rule of differential calculus, the u all over the x is equals to 2. Then let us differentiate the outer function also. In that case, I will have the y all over the u is equals to 4u raised to the power of 3. So I have differentiated the outer function and the inner function. Don't forget that from chain rule formula, the y all over the x is equals to the u over the x multiplied by the y all over the u. So don't forget that the u all over the x is equals to 2. So in that case, I will substitute 2. 2 multiplied by the y over the u, which is this 4u raised to the power of 3. So I'm going to have 4u raised to the power of 3 all over the x is equals to 2 multiplied by 4u raised to the power of 3. That is 6u raised to the power of 3. So don't forget that u is equals to 2x plus 4. So therefore, the y all over the x is equals to 6 into bracket 2x plus 4, 2x plus 4 raised to the power of 3. So we have been able to find the derivative of the composite function y is equals to 2x plus 4 raised to the power of 4 using the chain rule formula. The second question, we have y is equals to x squared plus 3 raised to the power of 9. The first step is to identify the inner function and the outer function. Therefore, I'm going to set u is equals to the inner function, which is x squared plus 3. X squared plus 3. So if u is equals to x squared plus 3, then y is equals to u raised to the power of 9, because I have set u is equals to this inner function. So therefore, y, which is the outer function, becomes u raised to the power of 9. Now the second step is to differentiate the inner function and the outer function. So I'm going to have the u all over the x is equals to 2x. And then we want to differentiate this outer function, y equals to u raised to the power of 9. The y all over the u is equals to 9u raised to the power of 8. So don't forget, for chain rule formula, the y all over the x is equals to the u all over the x multiplied by the y all over the u. The y over the x is equals to, don't forget that the u over the x is equals to 2x. So I'm going to have 2x multiplied by the y over the u, which is 9u raised to the power of 8. 9u raised to the power of 8. Yes, I'm going to have the y all over the x is equals to 2x multiplied by 9 into brackets. What is u? U is equals to x squared plus 3. Instead of writing u here, I'm going to substitute it as x squared plus 3. So I'm going to have 9 into bracket x squared plus 3 raised to the power of 8. So therefore, the y all over the x is equals to 2x multiplied by 9. That is 18x. 18x into bracket x squared plus 3 raised to the power of 8. So therefore, the derivative of y is equals to x squared plus 3 raised to the power of 9 is given by 18x into bracket x squared plus 3 raised to the power of 8.
And the last question, we have y is equals to x raised to the power of 10.
To solve this question, y is equals to x raised to the power of 10, you can use the power rule of differentiation, and you can also make use of the chain rule. Now let us differentiate. Let u is equals to the inner function, which is x. Then if u is equals to x, y is equals to u raised to the power of 10. The u all over the x, don't forget, it will be 1, and the y all over the u is equals to 10u raised to the power of 9. The y all over the x is equals to the u over the x, which is 1 multiplied by the y over the u, which is 10u raised to the power of 9. That is 10u raised to the power of 9. The y all over the x is equals to 1 multiplied by 10u raised to the power of 9. That is 10u raised to the power of 9. So substitute the value of u equals to x. In that case, I'm going to have 10 into bracket x raised to the power of 9. Now let us make use of the power rule of differentiation to differentiate this function. Don't forget that if you are given y is equals to x raised to the power of 10, if you make use of the power rule, the y dx is equals to the power will multiply the coefficient, which is 1. That's why I'm going to have 10, and the power will reduce by 1. I'm going to have x raised to the power of 10 minus 1, that is 9. So have you seen, if you make use of the power rule, you are going to get the same answer if you make use of the chain rule of differential calculus. So, but there are some functions that it will be very hard to differentiate using the power rule of differentiation. So we make use of the chain rule of differentiation.
Now, when do we use chain rule in trigonometry? Chain rule is used in trigonometry when we want to differentiate a trigonometric function that contains another function. Example, we have find the derivative of y is equals to sine 2x.
Don't forget, the first step is to identify the outer function and the inner function. In this case, I will set u is equals to the inner function, which is 2x. So u is equals to 2x if u is equals to 2x, then y is equals to sine u. The next step is to take the derivative of the outer function and the inner function. So the u all over the x, the u all over the x is equals to 2, and the y all over the u. Don't forget, if you differentiate sine u, you are going to get cos u. So the y over the u is equals to cos u. The y all over the x is equals to the y over the u multiplied by the u all over the x. So the y all over the x is equals to the y over the u is equals to cos u. So I'm going to have cos u in this place, cos u multiplied by the u all over the x, that is 2. So the y over the x is equals to 2 cos u. Now don't forget that I have set u is equals to 2x. So therefore I'm going to substitute the y all over the x is equals to 2 cos 2x. So the derivative of y is equals to sine 2x is 2 cos 2x.
The second example, find the derivative of y is equals to tan x squared.
The first step is to identify the inner function and the outer function. In that case, I'm going to set u is equals to the inner function, which is x squared. So u is equals to x squared. If u is equals to x squared, then y will be equals to tan u. The second step is to differentiate both the inner function and the outer function. So I'm going to have the u all over the x is equals to 2x, and the y all over the u is equals to, if you differentiate tan u, you are going to get sec square u. Now the y all over the x is equals to the u over the x, which is 2x, multiplied by the y over the u, which is sec square u. Sec square u. So the y all over the x is equals to 2x. Don't forget that u is equals to x squared. So I'm going to have 2x sec square x squared. So the derivative of y is equals to tan x squared is 2x sec square x squared. Now let's proceed to the third question.
Find the derivative of y is equals to cos 2x squared plus x.
Don't forget, the first step is to identify the inner function and the outer function. So in that case, I'm going to have u is equals to 2x, which is the inner function, 2x squared plus x. So in that case, y is equals to cos u. The next thing is to differentiate the inner function and the outer function. Therefore, I'm going to have the u all over the x is equals to 4x plus 1. The y all over the u is equals to, if you differentiate cos u, you are going to get minus sine u, minus sine u. Don't forget, the y over the x is equals to the y all over the x is equals to the u over the x, which is 4x plus 1 multiplied by minus sine u. So the y.
Here are some few questions that I want you to attempt on your own. We have question 1.